Okay guys, just a quick update. This tube is a 6AN8 and this is a 12AT7 tube. This one is used for generating the high F frequency. And this one is used for, I think, well, maybe also for power, for high frequency generation. In any case, whatever is inside, I need to look it up more precisely. There are two of each part in one tube, this one too. So which means that when I put it in the tube tester, I have to test one side and then the other. For this one, the same thing. Now they both tested good, so I don't think the tubes have any problems. I took out the electrolytic, and as you see, it's a closed can. Now there is a little bit of bubbling on top of this one. I don't know if you can see it, but so that makes me a little bit worried about its quality. It's a double 20 microfarad, I think, capacitor, yeah, 20 plus 20 microfarads, and it's rated at 180 volts. These notations aren't, I'm not familiar with these notations. I think this might mean something like watts, volt DC, and this is volt and the SP, I don't know, maybe peak voltage is 185. In any case, it's rated for reasonably high voltage. Now the thing is, I have two capacitors, but they're not 20 microfarads but 22, as you can see, and they are rated at 250 volts. So I think I'm going to go ahead and replace this one with two of these, well, we'll see. I don't think that should give too much trouble, because this capacitor is used for voltage regulation and not expressly for any high frequency modulation or anything. So that's it for now. I'll give you an update once I'm done. This is a cardboard enclosed double capacitor. And as you can see, the can is wedged into the cardboard tube. So what I'm going to do, and as you can see, I was already in the process of doing it, and when I realized I should make a little video of it, is I'm going to pry open this edge of the cardboard carefully so as not to rip it. And then I'm going to try to slide out the canister, which contains both capacitors, and then we'll take it from there on. Okay, now I managed to pry open the electrolytic for the power regulation, and as you can see, there is a paper roll inside. I don't know, it's coated in something sticky, and it looks a little bit like a fly trap inside, and it's just as sticky as anything else. Now what I did was I took away some of the rubber which was on top, or well, maybe it's a sort of a putty, I don't know, and then I started to pry carefully open the edges that were crimped around the bottom plate, which is made out of that a piece of cardboard covered with some putty, some brown colored putty. And then it just slid out, and as you can see inside there's just a long aluminum or aluminium strip which connects it to the can. So the can is really the ground of the two capacitors, and well, the two electrolytics are inside these rolls of paper and aluminum foil. So what I'm going to do is I'll see. You can't solder really to aluminum. So what I'm probably going to end up doing is cutting away this aluminum strip and then drill a tiny hole through the end cap, which you see here, this one, and then solder the two wires, because there are two capacitors. I'll solder the two ground wires here, and well, I'll see whether I can put the two capacitors side by side. I don't think so, but I can put them on top of each other. So if putting them side by side won't work, I'll put them on top of each other. And then I'll put their leads back through this cardboard separator and cover it up with some hot glue or something like that, and put the whole thing back into the cardboard, and that's it. So sit tight and stay tuned. Okay, so this is where I stand at. I removed the end cap from the can and cleaned out the interior, as you know from the other update, and I removed the cardboard from it. And now what I'm going to do next is I prepared the capacitors, as you can see. I soldered them one on top of the other, and they will go into the can like this. And then I will use, this was the upper side of the capacitor, but I will use the other side. Now, I don't know if you can see this, but I drilled tiny holes through the end poles of the old capacitor. There's another hole too, but I'll use the original leads that connected the original capacitors and put them through these small holes like this, and like this, and I'll connect them on the other side with little wires and some crimping to the new capacitors. And once that is done, I will place this cap back over the capacitors and then try to crimp back the edge over the cap so that it stays put. Anyway, that's the plan. We'll see how far we'll get, but I have good hopes it'll succeed. So until the next update. Okay, the capacitors are all soldered up and ready to go into the can. And as you can see, I'm getting geared to fit them in. So stay tuned. Well, and there we have it. One finished double cap. As you can see, I left the original ground wire on, but it really doesn't serve anymore. I just left it on for show. The real ground wire is the black wire here, and the two caps are each connected like this. So there you go. I did as good a job as I could, and it doesn't look too shabby. So well, it's back into the RF generator, and let's see what it does. Okay guys, I remounted the refurbished electrolytic. Now let's see what it does, if we get a pop or not. That's nice. The pilot light burns, so that's good. And we have filament burn on the lower tube, the 1287, and we have filament burn on the upper one too. That's perfect. So I think this was a successful operation. Okay, so I'll get back to you guys for a last update after I replaced the BNC, or rather placed the BNC connectors. So stay tuned. Okay guys, well, the new BNC connectors are in the box. As you can see, I connected them up, and it looks okay. Well, now of course comes the test. Now we have to see whether it will work or not. So give me a minute to set it up, and then we'll see what we'll see. So stay tuned.